Hello everyone, I hope you all are doing good. So I'm uploading another video for you all and I'll continue from where I have left in the previous class. So those who haven't gone through my previous video, please go through it once, then only you will be able to answer these questions because this topic is interlinked with previous video. That is why you need to refer that video. So today's question is, the number of atoms in 0.1 mole of triatomic gas is, the value of Na is given. Usually we know the value of Na, but sometimes it might be given, so you can use this value also. So there are four options. Now to calculate the number of atoms, I have given you the formula N into Na into atomicity, where N is the number of moles, Na that is the Avogadro's number, and atomicity you can easily deal with that. Now number of moles, what about the number of moles? Number of moles is given over here, that is 0.1, and Na that is 6.02 into 10 to the power 23, and atomicity, because the gas is triatomic, that means the atomicity is 3. Now you can solve this one. 0.1 means 1 by 10 into 6.02 into 10 to the power 23 into 3. Now you can multiply 6.02 with 3, so the number will be 3 2 is 6, 3 0 is 0.36 is 18 into 10 to the power 23 divided by 10. Now there are no options which includes two numbers before the decimals. You can clearly see over here. That is why you need to shift this digit one digit in front. So for that, this is 10. 10 means if you don't want to write this 10, this decimal should be placed between 1 and 8. It should move forward. That is why the value will be 1.806 into 10 to the power 23. Now you shouldn't be writing 10 because instead of 10 you are shifting one decimal forward. That is why the value will be 1.806 into 10 to the power 23. That is why it is option number B. So this is how you must be solving. The similar way, the number of oxygen atoms in 4.4 gram of carbon dioxide is, here also you are asked about the number of atoms. That is why number of atoms means N into Na into atomicity. So N, that is the number of moles. You are not given the value for the number of moles, but we know that number of moles means given mass, that is 4.4 divided by molar mass of carbon dioxide, that is 44, into Na, that is 6.02 into 10 to the power 23. You can use that previous value into atomicity. Now even though carbon dioxide is triatomic, but you are simply told to find out the number of oxygen atoms. In this carbon dioxide, you only have 2 oxygen atoms, even though its atomicity is 3, but since only 2 oxygen atoms present, that is why you must simply write 2. Now you can solve this one. So if you remove the decimals and if you cancel this one, it will be 10. So it will be 6.02 into 10 to the power 23 into 2 whole divided by 10. And you just multiply this with the 2 with 6.02, it will be 12.04 into 10 to the power 23 divided by 10. Now again, you can check the options that in none of the options there are 2 digits before the decimal. That is why you again need to shift this decimal. And if there is 10, you can shift the decimal one place before. That is why it will be 1.204 into 10 to the power 23. That is why it is option number, basically that is option number A. So this is how you must be solving it. Now, after understanding some basic concepts of mole, we'll just move on and we'll study about another topic, and that topic is stoichiometry. Now, few other persons might pronounce it differently, but I usually pronounce this as stoichiometry. And it is nothing, it is actually a calculation which is based on a balanced chemical equation. Here, you must be taking one equation and that equation should be perfectly balanced. If the equation is not balanced, your prime duty is to balance it. Sometimes the equation itself will be balanced because those chemical reactions might be simple reactions. For example, if I take this reaction C plus O2 CO2, now this is a very simple chemical reaction where carbon is combining with oxygen to give carbon dioxide. And you can clearly see over here that this equation is perfectly balanced because there's only one carbon in the product, 2 oxygen and 2 oxygen in the product give carbon dioxide. That is why the equation is perfectly balanced. Now since you all are not using any numbers to balance the equation, and if there are no any numbers written over here, it usually refers to 1. That means there is 1 carbon, 1 O2 and 1 CO2, and here 1 itself means it is 1 mole. So you must be taking 1 mole of carbon and it will combine with how many means 1 mole of oxygen, because there is nothing means there is 1, and obviously carbon dioxide there is nothing in front, that means it will give 1 mole of carbon dioxide. So you must understand, if this is your balanced chemical equation, you must understand that 1 mole of carbon is actually combining with 1 mole of oxygen to give 1 mole of carbon dioxide. So this is what this statement says. This statement, 1 mole of carbon combines with 1 mole of oxygen to give 1 mole of carbon dioxide. This can also be understood in terms of atomic mass or molar mass. Now we all know that 1 mole of anything means their atomic mass. That is why 1 mole of carbon means it is 12 gram, because the atomic mass of carbon is 12. Similarly, 1 mole of oxygen means that is 16 into 2, that is equal to 32 gram of oxygen, because the atomic mass or the molar mass of oxygen is 32. Similarly, 1 mole of carbon dioxide means you have to find out the molar mass of CO2. It will be 12 plus 16 into 2, that will be 44 gram. That means 1 mole of carbon is equivalent to 12 gram. Similarly, 1 mole of oxygen means 32 gram and 1 mole of carbon dioxide means 44 gram. That is why indirectly we can even say that it is 12 gram of carbon. It is a 12 gram of carbon which will combine with how many means 32 gram of oxygen, and it will produce how many carbon dioxide means it will produce 44 gram of carbon dioxide, because this molar mass or the atomic mass is always equal to the number of moles. It is equal to the moles. That is why 1 mole of carbon, that can be easily written as 12 gram of carbon. Similarly, 1 mole of oxygen means 32 gram of oxygen, and 1 mole of carbon dioxide means 44 gram of oxygen. That is why this second statement is also correct. Now this can even be understood with respect to volume 9. So here 1 mole of anything, 1 mole of carbon, carbon dioxide, water, anything else, 1 mole of anything occupies 22.4 liter at STP. You must remember it at STP. So at STP, 1 mole of anything occupies 22.4 liters. Similarly, 1 mole of oxygen too will occupy the same volume, 22.4 liter. And 1 mole of carbon dioxide will also occupy the same volume, that is 22.4 liter. So we can even say it indirectly that it is 22.4 liter. That is always equivalent to 1 mole of carbon. 22.4 liter. 22.4 liter of carbon is actually combining with how many means 22.4 liter of oxygen, and it is producing how many carbon dioxide? It is producing the same amount, that is 22.4 liters of carbon dioxide. Okay, so this is with respect to mole, with respect to atomic mass, or with respect to volume, everything will be the same. You can even do this crisscross. That means you can even tell that 1 mole of carbon will combine with 32 gram of oxygen, because 32 gram of oxygen itself means 1 mole of oxygen. We know that. That is why 1 mole of carbon can easily combine with 32 gram of oxygen to produce how many carbon dioxide? 22.4 liters of carbon dioxide, because 22.4 liter of carbon dioxide itself means 1 mole of carbon dioxide. That means ultimately it is the same thing. You can even refer 1 mole of carbon will combine with 32 gram of oxygen to give 22.4 liters of carbon dioxide. Or you can even say 12 gram of carbon combines with 1 mole of oxygen to give 44 gram of carbon dioxide, because they ultimately means the same thing. You can even tell 22.4 liters of carbon will combine with 1 mole of oxygen to give 44 gram of carbon dioxide. Okay, there might be so many combinations possible. That is why you must understand the topic. Now here you can easily say that 1 mole of carbon, so 1 mole of carbon will combine with how many grams of oxygen? That is 32 grams of oxygen, and it will produce how many liters of carbon dioxide? That is 22.4 liters of carbon dioxide. Now you need to have the thorough knowledge about the moles, volume in liters and the molar mass and the atomic mass. So this is your stoichiometry. This is how you must be starting the calculations, but this is the basic thing that you must remember before proceeding. So here are some questions related with stoichiometry. So let us solve this. The mass of CO2 produced by combustion of 30 gram of carbon is. Now first of all, before approaching, you must be able to write the balanced chemical equation. Here, carbon dioxide is being produced by combustion of 30 gram of carbon. Yani carbon is being combusted. That means it is actually being reacted with oxygen. Combustion means you are reacting with oxygen, and if you react carbon with oxygen, it will obviously produce carbon dioxide. So this is the equation. Now after writing the equation, you check it whether the equation is balanced or not. Here the equation itself is very much simple and equation itself is balanced. That means you don't have to balance the equation. Now you must move forward. Here the mass of CO2 produced. Here you need to find out how much mass of CO2 is being produced. And you are given the mass of carbon. That is why you must be comparing the atomic mass of carbon and the molar mass of carbon dioxide. You must be comparing mass with another mass. That is why this type of question is also referred as mass-mass relationship. So here mass of one carbon is given, and you are just told to find out the mass of carbon dioxide. That is why you have to compare its atomic mass or the molar mass. So for carbon, the atomic mass is 12 gram. You all know that is 1 mole. 1 mole means 12 gram. You don't have to balance it. Here, CO2, you don't have any numbers over here. That is why it is simply 1 mole. 1 mole, it will be 44 gram. We have done this in the previous case. That means 12 gram of carbon is actually giving 44 gram of carbon dioxide. That is why 12 gram of C will give 44 gram of CO2. So this is the information that we will get from the balanced chemical equation itself. Isn't it? So that is why 12 gram of carbon will give 44 gram of carbon dioxide. Then 1 gram of carbon will give how much? That is 44 by 12 gram of carbon dioxide. But you are asked about 30 gram of carbon. That is why 30 gram of carbon will give, that is 44 by 12 into 30. Now you must cancel it. 4 3s are 12, 4 1s are 4, 4 1s are 4, 3 1s are 2, 3, 3 10s are 30. That is why 11 into 10, that will be 110. That is why it is option number A. So this is how you must be solving the mass-mass relationship question. There's another question. The number of moles of hydrogen molecule required to produce 20 moles of ammonia. That means you must be able to write the balanced chemical equation first. That is hydrogen. Now to produce ammonia, so ammonia should be produced. Now to produce ammonia, hydrogen must be reacted with another element, and that is nitrogen. And this will be the equation. Now check it whether the equation is balanced or not. No, it is not balanced. Now you have to balance it. Now there are 2 nitrogen atoms, so you must be putting 2 over here, and 2 3s are 6. There are only 2 hydrogens. That is why you must write 3 over here. So now the equation is perfectly balanced. Here you don't have to find out the mass, atomic mass or the molar mass, because here you are simply asked about the number of moles. And you know from the equation itself that 3 moles of hydrogen is combining with 1 mole, nothing written in 1 mole of nitrogen, and it is giving 2 moles of ammonia. That means from the equation itself, it is clear that 2 moles of ammonia is being produced from 3 moles of hydrogen. That is 3 moles of hydrogen. So you have to just write the known value in front, because 20 moles of ammonia is given. That is why I'm writing the information about ammonia first. So 2 moles of ammonia. From the equation itself, 2 moles of ammonia is giving 2 moles of ammonia is actually being produced from 3 moles of hydrogen. That is why 2 moles of ammonia equals to 3 moles of hydrogen. Now 1 mole of ammonia will obviously require 3 by 2 moles of hydrogen. But how many moles of ammonia is being produced? That is 20 moles of ammonia. That means 3 by 2 into 20. Now how much hydrogen do you require? If you cancel this one, 3 tens are, and again 3 tens are is 30. That is why 30 moles of hydrogen is actually required to produce 20 moles of ammonia. So this is the way, this is the method. So let us solve a few more questions related with stoichiometry. So take this another question. The volume of CO2 produced at STP when heating 9.85 gram of BaCO3 is, here the atomic mass of Ba is given. Now your first duty is to write a balanced chemical equation. So BaCO3 on heating, BaCO3 is simply heated. Here it is not combusted. You shouldn't be reacting with this with oxygen, because here the word combustion is not there. You are simply heating BaCO3, and if you are heating BaCO3, it will simply decompose to give BaO and carbon dioxide gas. Because you have to find out the volume of carbon dioxide gas. That is why this will be the equation. Now try and balance it. Here 1 Ba, there are 3 oxygen, there are totally 3 oxygen, 1 carbon, means the equation is perfectly balanced. Now here, the mass of BaCO3 is given, that is why you have to find out the atomic molar mass of BaCO3. Because mass is given, so you have to compare mass with the volume, because you have to find out the volume of carbon dioxide. That is why mass should be compared with the volume of carbon dioxide. That is why for BaCO3 you must be calculating its molar mass. So let's do it. So 137 plus for carbon is 12, for oxygen it is 16 into 3. So 137 plus 12 plus 16, 3 is 48. So 8, 19 into 8, 19, 7, 4, 5, 6, 7, 8, 9, 197 gram. But for carbon dioxide, you don't have to find out the molar mass, because you are asked to find out the volume of CO2 at STP. And the volume will be, since you only have 1 mole of CO2, that is why the volume will be 22.4 liter. Now from the balanced chemical equation itself, you can clearly say that it is 197 gram of BaCO3 will be producing how many volumes of CO2? It will be producing 22.4 liter of CO2. So from the balanced chemical itself, we can easily say that this much mass of BaCO3 will be producing this much volume of carbon dioxide. Okay, so this is a mass volume relationship question. So you can easily compare the mass of one compound with the mass of another compound if it is a perfectly balanced chemical equation. And 197 gram of BaCO3 is producing this much liter of carbon dioxide. That means 1 gram will be producing how much? It will be 22.4 divided by 197. But you are given how many mass of, what is the mass of BaCO3 that is given? It is not 1 kg, 1 gram. It is 9.85. So 9.85 gram of BaCO3 will be producing 22.4 divided by 197 into 9.85. Isn't it? So you must be multiplying 9.85. Now remove the decimal. So you can simply remove the decimal and put 100 over here. This should have some connection. So 197, it should be 5 times, I guess. 5 7 are 35, 5 9 are 45, 45. Yes, that is 5 times. So multiply 5 and 2, 22.2. So 5 4s are 20, 0.5 2s are 10, 11. No, it's 12, 2. 5 2s are 10, 11. Divided by 100. 100 means you have to set the decimal twice in the forward direction. That is why it will be 1.12. That is why it is option number C. Moving on to another question. What is the weight of oxygen required for complete combustion of 2.8 kg of ethylene? So what do you know ethylene? Ethylene means there must be double bond between the 2 carbon atom. It means simply 2 carbon, and there must be double bond, and the remaining it will be 2 hydrogen. Here also it will be 2 hydrogen. So simply you can write it as C2H4. That is simply C2H4. Now you are combusting this, means you are reacting this with oxygen, and the products that you will be obtaining will be, while combustion of any of the hydrocarbons, you will be obtaining the 2 products, that is carbon dioxide and water. Now you have to balance the equation. There are 2 carbon atoms, you have only 1 carbon, that is why you must be placing 2 over here. There are 4 hydrogens, but only 2 hydrogen over here, so again you must be writing 2 over here. Now if you do like this, carbon is balanced, hydrogen is balanced, but what about the oxygen? 2 2s are 4 plus 2, 2 ones are 2, so there are 6 oxygen, but only 2 is written over here, that is why you must be writing 3 over here. Now you have to find out the weight of oxygen, and the weight of acetylene is given, that is why you have to find out the weight, atomic mass. So see, for carbon it is 12 plus 2, 1 into 4, so 12 24 plus 4, that is 28. And for oxygen, 3 into, for oxygen that is 16 into 2. So 3, 16 2s are 32, and you have to multiply this, so 96 gram. You must be writing this through continuously, because this is the number that is being used to balance the chemical equation. Okay, so from the equation itself, from the balanced chemical equation itself, it is clear that 28 gram of C2H4 actually requires how many grams of oxygen? It requires 96 gram of O2. And if 22 gram of acetylene requires 96 gram of O2, 1 gram of acetylene will require 96 by 28 gram of O2. Okay, now how many acetylene you are taking? How much acetylene you are taking? 2.8 kg. Now it is not necessary to convert the unit, because 96 is in gram. Here 28 is also in gram, so gram and gram simply gets cancelled. It will be a unit less number, and if you multiply this with 2.8, the answer will also be in gram, kg itself. That is why 2.8 kg of acetylene gives 96 divided by 28 into 2.8. So this is how you must be doing it. Just remove the decimals, so divided by 10, it will be 28 by 10. This simply gets cancelled, that is 96 by 10, and that is 9.6 kg. That is why your answer is option number C. So this is how you must be doing it.